City District, and my topic today will be on district design tips and tricks, or more so just some microstation stuff that you can do on your district designs. What I'm going to go over today basically will be some of John Collato's how-to videos, I guess where they're located, just briefly show where that's at, and go through the naming standards and the importance of them. Just show you where those are at, and then show some tips here on referencing base maps in the RS drive and why they could be useful, and also scaling up some areas and using them as a reference within a drawing. And lastly, I can show you quick how to create a cell. So let me share my screen here. Firstly, I'll just show you John Collato. If you guys don't know who he is our DOT microstation wizard. He knows pretty much everything there is on microstation, and he's got, for new users, he's got a bunch of videos out there located on the S drive under the, I'm going too fast here. I'm going to apologize in advance if I go too fast. I only got a 30-minute window here to talk about a lot of stuff, so I apologize. Bear with me, please. In the S drive, under the support folder, there is some how-to, a how-to folder, and there's a bunch of videos in here that John basically will upload. If anybody poses a question to him, he might record it and put it in here. So some of the stuff that I talk about today could already be in here. I guess I'm not sure. I haven't been through all the videos, but for you new users out there, this would be a good start, I guess, on learning some new things in MicroStation. Again, that's the S drive, support, and the how-to folder. So moving on to the naming standards. Firstly, I'll just show where those are at in the design CAD standards manual. So on the MyDOT homepage, if you go to manuals and you click into the CAD standards under engineering here, there's a CAD standards link. If you click on that and you go under the resources, it'll show you the CAD standards manual. And I believe this is on in the table of contents. It's on page 4, where you can find the appendix for plan production file naming standards. And these are all links. So if you click on this, it'll take you right to the appendix. And basically what you're looking for when you name your MicroStation files is these on the left here. The description is in the middle. So why these are important, specifically the prefix, is that MicroStation has preloaded CAD standards for each drawing. The prefix for the file name kind of determines which CAD standards are loaded into the drawing. So you might have different CAD standards, or you will have different CAD standards, or line styles, cells, etc. for each drawing you're working in. And I'll show you a quick example briefly. Most of you probably know this, but for new users, this might be something new. So we'll just do a quick example using bringing in a typical section drawing. So firstly, I'm going to click MicroStation, open up a new MicroStation drawing. If I click new file, I'm just going to save it to my desktop to show you as an example. And I type in, I find that file name 030TP _, and this just designates the page number you're going to be working on. So since it's my first drawing, I'll put in 001, and then lastly I'll just put the description in here. So again, the prefix is the most important part. So 030TP _001, and I'll just call this existing typical. Save it to my desktop. and these preloaded standards should be coming in. One way to tell that is it's trying to find it in this S drive here you can keep an eye on. But another way to tell if your CAD standards came in will be in the upper left corner. I believe these are called your workflows. And then you should have a drop down here. If you do not have a design workflow, your CAD standards did not come in, and that would be more of a John Collado question. I would get a hold of him and ask him why your CAD standards didn't come in. But if you click on this design workflow, you should have, and if you labeled it correctly in the file name, you should have a tab or a ribbon here. I think these are called. It looks something like this, 030 TP typical. And if you click on that, you can see here that your line styles all came in accordingly to this drawing. And also your cells did too. You have all these different cells for this typical section. And I think you have different pattern areas too for this typical, and et cetera, et cetera. If you did not label this correctly, if I forgot the T, this will not come in. It might show you like something like no name specified or something, and you might not get all your cells you need for this drawing in. So it's pretty important, again, to make sure that you label that accordingly to this appendix here. So, okay, moving on to referencing base maps in the RS drive. So I'm going to open up a file that I had already created. Since I don't have much time, I already made a scope of work file earlier this year that I'll just use for this example. So, okay, there's my scope of work. Why this could be useful, I guess, is some of the maps that you could reference in here could be used to creating the scope of work. For instance, that's exactly how I got these polylines in for my highways here. I was able to just reference in a base map and then just clip that out real easy. And I'll go through that right now and show you how to do that quick. The first thing that I would do is I would make sure that I'm using a consistent coordinate system, and I'll show you how to do that. So if you're in your design workflow and you go to this main tab, you'll have this ribbon or macro here that says attach mosaics. You want to click on that, hit the drop down, and you want to click on this geographic coordinate system. And MicroStation has these already preloaded or preset in MicroStation. You just got to pick which one you're working in. And I like to typically stay consistent with wherever my project is. That's where I pick as far as which county I'm going to use here for this. And you want to be in this DOT County 2011 folder. And because our district's in Valley City, I'll just use Barnes County for now, but I want to stay consistent using this, I guess, bringing in my references. This is also useful too in open roads and just getting used to this, because if your surveyor is out there, shooting stuff and you want to bring in some points that he had out there, this is what you would use. You would pick the county he was working in and work with your surveyor on getting the correct coordinate system. So once that's set, I can click out of this and go back into my design workflow, scope of work, and now I'm going to reference in using this reference manager tool some of these base maps. Okay, so if I hit tools, attach, and I go into the R drive, and I go into the projects folders, and I scroll down all the way to the bottom, there's a folder called base maps. And then I'm going to go to projected coordinate system here, and there's a bunch of these maps that are loaded in here. I don't know who made these, but they can be beneficial to use for scope of work, you know, finding or rastering in mosaics, and I'll explain that in a second, and just creating maps maybe. So there's one here for district maps or district boundaries. You can click that, double click that, and make sure that you use the geographic reprojected option here, since we set a coordinate system. So I'm going to bring that in. I think it came in, fit view, and you can see that came in. This might be handy for maybe using, if you're trying to create a map for a district-wide project striping, or, you know, may want to use this for a title sheet or scope of work. You could just clip these out. I'm not going to show you how to do that. I don't have enough time. So that's just one way you could use this. There's another map you could bring in. Let's go back to this design scope reference manager. I'm going to take that. I'm going to detach that off. Right click, detach, and I'm going to bring in on the R drive project. Scroll down. Base maps, project coordinate system. There's one here for state highways. Now this is the one I use quite a bit for just clipping out segments for my scope of work. Again, we want to be in geographic reprojected, and it'll bring in all the state highways in North Dakota. And for example, this stretch right here that I used, I believe is right here. I just clipped this out and used that and worked off that in my scope of work. So it's pretty easy. You don't have to worry about, you can save some time, you know, drawing a little bit. Also, I wanted to show one more thing, just the use you could use this for rastering in or bringing in a mosaic. It's kind of handy. So again, if you're in the design workflow, go to, let's see here. Go to the main tab and go to this attach mosaics drop down. And if you attach this DES statewide project, you'll get a bunch of grid lines. Again, we want to be in geographic reprojected. Hit OK. And you'll see all these grid lines. This is how you will bring in mosaics. Now, the highways will help you find where you are, I guess, is what I use it for. So the highways aren't labeled, but I guess I know where, you know, Valley City is just from looking at several maps. This is Valley City's city loop here, I know, so I can just highlight this grid. Okay, and then I can hold control. I can highlight this grid, and I can go back into that scope of work, or no, the main ribbon here. Attach mosaics, drop down, and I can just hit attach mosaics, and it should bring in 2 rasters in Valley City. So now I have this that I can clip out. I can work into for whatever I need for my drawing here. So can be beneficial. Again, there's a bunch of maps in that folder that might be useful to you. So I would recommend just spending some time looking through those. They can be beneficial. So okay, I'll move on to the next thing here. Let me detach these. Attach my raster. Okay, So the next thing I'm going to talk about is just a tip that can be used. You can scale up areas as a reference, and I'll explain what I mean by that here in a second. But this can be used for different types of design sheets, like layout sheets, scope of work sheets, and typical sections. It's basically used to show a clear detail of a small area on a plan sheet. So, for instance, I have the scope of work here, and say I wanted to detail out some work that's going on at this interchange here. This would be a good tip how to blow that up. So I could basically take this area, reference it out in this nice space here, and kind of blow it up. So for the spirit of March Madness, I drew a little Yukon logo here. I'm going to show you what I can do with this in a second. So the first step on how you want to do this is you want to attach a reference. You're going to attach the drawing you're working in as a reference. And I know this sounds confusing, but I'll explain as I go. So I'm going to hit attach reference, and I'm going to attach this the same drawing that I'm working in. And for the sake of this example, I'm actually going to be in coincidental world here. Okay, yeah. Hit OK, and basically what that does is it put basically a copy over this drawing that I'm working in. And what I'm going to do is I'm going to now just create a boundary of the area that I want to scale up, and that in an area over here, I'm going to be scaling up that husky and put it right here. So first step would be create the boundary. So I'm going to go back into my scope of work tab. And it doesn't have to be a circle. You can use whatever you want as long as it's in an enclosed boundary. I'm just going to use a circle just because it's quick. A quick tip here for your drawings, if you want to change your line styles really, really quick, all you need to do is hold the Alt key, and you can click on one of these lines, and it'll match exactly that line style that you want to work in. So again, hold Alt and just click this, and it'll change real quick. So I want this light blue line, and I'm going to put it around, let's say, I don't know, right there. Okay. Now I'm going to clip out that reference so that just this, I'm just going to reference this area into that larger area, I guess. So I'm going to make sure this is highlighted in my reference. I'm going to hit clip reference, and you should have a toolbar that comes up. I always dock mine over to the left here, so it always sits in this spot, but yours might be popping up anywhere in the screen. But the method of clip, you want to make sure that element is set on, and you want to just clip the element that you created. I created this element to the circle, so I'm going to hit this, and you can't tell, but everything clipped out within this circle here. Now, all I got to do now is move this reference into that bigger area. So I'm going to hit the button to move reference here, click the circle, and I'm going to pull it out. And I'm going to bring it, I don't know, right about here. Okay. Next step is going to be to scale this up so it's visible on my plan sheet. So I'm going to hit the scale reference button. Go over to my tools again, my tool menu, and I like to do this by points because it's easier for me to see. I'm just going to click there. I'm going to click another spot here, and I'm just going to drag. You can see it's getting bigger. Maybe. So that's getting pretty big. Let's see how it looks. I could go a little bit bigger. And there you go. So now basically what I did is I scaled this area or referenced this area and put it here. And now I could keep drawing in here, and everything that I draw in here will show up in that circle. So if I go back to this scope and I just make some lines behind this guy, that should show up in that circle, and it does. So another cool feature that you could do with this would be then if you want to clearly label some things in here, but also keep these lines and say you're drawing over there, you could shut these levels off in this reference. So I'll show you how to do that quick. So if you go back into your scope of work tab here and you click the level display button, you can see that your reference is right here. So this is just what's in this little circle. So I can shut these lines off by using the change level tool here. So if I click that and click this line, everything disappears in this reference, but it should be still there in this reference. And so now I could go in, clearly label this, and or start dimensioning this, which will be my next point here, dimensioning. If I wanted to dimension this, I delete that. If I wanted to dimension this right here, it wouldn't look so good, small. So to dimension something, you hit your scope of work tab, and then you have to make sure that you're in the dimension element or dimension linear tool. Make sure that your one of these is clicked on, and I'm just going to try to do a quick dimension, and you can see how you wouldn't be able to tell what I was dimensioning on this plan sheet, right? So you can see that's 63.28 feet. Now, if I go to my reference, as long as I make sure I snap to something, an element within this reference, it'll still say 63.28 feet. That's the exact size it is when it's this big. But if I don't snap on anything, you'll see that that changes to about 8,000 feet. So you want to make sure that you are snapping to the elements within this reference to kick that dimension in. So this could be used for a lot of things, really. Intersection layouts, I guess, if you wanted to blow up parts of an intersection, or if you wanted to scale up a city, maybe you have to go through in a scope of work, and you wanted to detail some things out in there. This would be a good method to use. Or if you wanted to scale up maybe a shoulder treatment on a typical, if you want to show how you're going to tie in maybe, or show a bevel or something, this would be the method to use. So that's pretty much sums that up. One last thing then would be creating a cell. I'll go through that real quick. Now, I would only recommend you creating a new cell, I guess, if you find yourself drawing the same detail over and over. We have CAD standards to follow, so make sure that you're following, I guess, the CAD standards using the cells that are preloaded in the MicroStation. But if I were to keep drawing this beautiful Yukon logo, I would maybe want to consider making a cell. So how to do that would be, if I go to the scope of work tab and I click on the cell button here, and I go to the toolbar should pop up. And if I click this browse cell button, this menu button, it should bring up a cell library. Now this is the one that's defaulted into MicroStation, but all I got to do is hit File, New, which is what I would recommend doing, because if you save cells into this, it might get overwritten and you might lose all the cells that you create. So I recommend starting a new one and maybe saving it in your local drive, which is ours is in Valley City is the F drive. and we have a folder called VC, and then we have a design folder, which is where I'll save this one. And I'll just call it VC district cells. I already have one made, but I'll just overwrite it. So now this should be changing. This new cell library should be blank. Take a second here, and there it is. So then to create a new cell, you can see this is grayed up, grayed out. So I need to do two things to create a cell. One is selecting everything that I want to be a graphic, which would be just this here. You can see that's all highlighted. And the last thing I need to do is, again, going into that scope of work ribbon or tab, is hitting this drop down here where it says place active cell. And I just need to define a cell origin. And I'm just going to put that right in the middle of its nose. And basically what all that does is when I click this cell, it's just where it's going to point and inset the cell, I guess, into the drawing. So I'm going to click this, and you can see that this create button became active. And I'm going to hit that, and you just got to give it a name. So I'm going to call this Husky, and I'll just say Yukon, and leave that as a graphic. And I'm going to hit create, and it's done. So all I got to do now is just double click that, and now I have a cell, and I can stamp that how many times I want. And that's pretty much all I have for cells and all I have for my presentation. I'm gonna pass it on to Corey. I think I'm over my time. So if there's any questions on this, you can maybe ask me after the presentation, or just call me directly, or even call John Claudio. So that's all I had today, and thanks everybody.
All right, let me my presentation up here, and I don't know where my teams went. Can everybody see my presentation?
Yep.
Okay. So I got tasked with doing structures, and I guess first off, my name is Corey Wagner, technician in the Valley City District. I am by no means an expert on structures. So if anybody has different information than I present today, please let me know, and we can definitely talk about it. I've done 5 complete bridge replacements, 2 deck replacements, and a handful of deck overlays. I've also been a district bridge inspector for the first 12 years of my career. So I kind of know a little bit about bridges, but like I said, I am not an expert. And I am just going to teach you what I've learned, I guess. And I'm not going to talk about everything involved with building a structure, just some of the things that I felt were important to cover. So with that, we'll get going. Safety is always a big factor. You know, some of these things, you know, reflective clothing, that should be common to everybody at this point. I mean, it's just a requirement. But on structures, there's a few additional hazards you got to look out for. You want to make sure you wear your hard hat. Last year, we did a bridge project, and while we were driving piling, there was a shackle such as this up on the hammer. And the contractor's policy was that they were supposed to tie that pin with a wire so that it wouldn't come out. and they happened to forget one. And I would say the hammer was probably 30 feet in the air at this point, and the pin came out. It rattled loose and it fell. And one of their workers was standing by the hammer, uh, watching, making sure things were right. And that pin hit him in the back, right by his right shoulder blade. He let the hammer go about 2 more hits and pulled the rope and shut it off. And he had to go. Luckily, it was no severe injury, just a pretty good bruise, but could have been worse if he wasn't wearing his hard hat or, anything. And I was only standing probably 5 feet away from the guy. So just something to be aware of, them falling hazard or hazards from above, and not just when the crane is operating. If you're under the bridge checking something and they're working above you, make sure you're wearing that. Safety glasses. Driving piling, there's grease everywhere. Everything gets covered. Sure don't want to get that in your eye. Hearing protection, when they're running the hammer, it can get quite loud. And then, if you say you got to walk beams to shoot them, or you got to get up on top of the pier, use a lift, whatever, just make sure you're wearing that. So kind of one thing we all need to look out for. So whether you're the surveyor or not, just something good to know that when you're staking, you want to try to use one common set of benchmarks and control points for everything. That way, every part of your structure is the same.
Muted yourself, Corey.
I don't know when I got muted here. But you want to make sure that your bridge gets built the same from end to end. You don't want to have one abutment that's 2/10 lower, So just be aware of that. It just makes sure you have repeatability in your project, in your bridge. And I typically use a level and a total station. The best accuracy and that repeatability. I trust my equipment, so that's what I use. So a big thing with a bridge is your piling, because that's your foundation. We support our bridges with that. So if your piling's not right, your bridge isn't right. And this, here's an example of a plan sheet and a few things that you want to look at. Your piling lengths. Right. So right here, for this pier, we got 130 foot of pile planned. Not always going to be that 130 feet. It all depends on how your pile driving goes when you reach bearing. It'll also give you the pile sizes for each of those locations. You see, this is a HP 14 by 102. Here's a HP 14 by 73. So a little bit different. And I guess if you don't know, the 14 is 14 inches. And then the 73 is pounds per foot. So just be aware of that. That'll come into play with your bearing calculations. Required bearing. You see that here. You'll need that to make sure you hit that bearing. because the designers have calculated the load that that pile needs to carry to support that bridge. Bearing elevations as far as your beam seats. So here, elevation shown are top of finished concrete. So that would be where your beams sit on your abutments and piers. That's information you need to know because you need to, a lot of times plans don't have like your pile cutoff elevation, but you can calculate them from these beam seat elevations. So another thing to be aware of. And then the bearing formula. We'll go into that a little bit more here in a little bit, but formula looks a little daunting, but it's really not that hard to calculate. Just some common tools. The 100-foot tape measure or 50, I guess. I prefer a steel tape. I guess I got a picture of a nylon tape, but you want to get accurate measurements on your piling because you'll use those measurements in your bearing calculation because it changes the weight. The lath and the soapstone used for marking the piling while driving. And typically, like when we drive piling, we use 2 people to make sure that we've reached bearing. 1 marking, 1 measuring. Just get that second set of eyes. And then a caliper. So for quite a few years, I used the tape measure to measure your marks in 10 blows. And it's pretty hard to try to get a reading on what that penetration was. And then I decided to try a caliper. I set it to what I'm looking for based on the other factors, and that made it a whole lot easier. So always looking for things to make the job easier. So here is some hammer data I pulled off the internet, and almost every hammer out there you can find this information, unless you got some oddball hammer that is 100 years old, but it's all out there, and usually the contractor should have this information too, so that you can figure out your bearing. And the highlighted information here, we'll use that a little bit in a couple slides, but those are some things you'll need, and that information came off of this sheet. So just be aware of that. There's also this chart out there for a lot of hammers, and it's come from the hammer manufacturer. Shows the same hammer on that last slide. The pile set blows per inch doesn't really mean a whole lot to us in the way our formula is, but the big thing is your blows per minute, the stroke, and the energy. So it kind of gives you another double check on what you're doing as far as determining your bearing. So this here is part of a spreadsheet that we've created and changed and updated over the years. It aids tremendously in calculating bearing because you don't have to hand calculate that formula over there on the right. But a few things. So this required bearing, you would pull that off of that plan sheet I showed earlier. And this will factor into the next slide as far as whether you've met bearing or not. Here's that piling size, piling weight. Those 2 things, this piling weight actually calculates your pile weight in this chart based off of these lengths. And then just hammer info. Here's that highlighted info from a previous slide, because you need those to fill out this formula. And then just the pile that we use, I just put a few links in just to give us some numbers. So this formula, like I said, it's not hard to calculate, but it's a lot easier when you have a spreadsheet set up and it does it for you. One thing to note, when you are calculating this by hand, the S here, the average penetration of pile in inches per blow for the last 10 blows, that is for one blow. If you put that, if you say you're looking at a 1/2 inch as your number you need, but if you put a 1/2 inch in, you're going to have a really low bearing value. So you got to make sure you're calculating it with one blow and not the 10. So here's the chart that comes off of that spreadsheet. You see it's got penetration there on the left in 10 blows, and then your blows per minute across the top. And then everything in yellow has met the bearing capacity required off the previous slide. So this is an easy way. I can go out there with my iPad. I can put in my information, as the number of blows changes, I can see what penetration will meet bearing. It's just a nice, easy way to do it. Every pile is going to be different, but like I've noticed over the years that, like, when you do a 14 by 102 or a 14 by 73, you're probably going to be pretty close on the criteria you need to meet to hit bearing, whether you're at 250 or tons or 150. So you kind of start to see that repeatability with it. So there is an app out there. It's made by Klassen Industries. It is for Apple and Android, and it'll use your phone or iPad's microphone to listen for the blows, and it'll register your blows per minute based on the time, and then it'll also give you a stroke number for the hammer, which is pretty handy because it's hard to tell how much stroke that piston has when you're standing on the ground and that hammer is 10 to 40 feet above your head. And even if you're pounding on a pier in the median and you're standing up on the embankment over by the abutment, you're still not getting a super accurate estimation of what your hammer stroke is. So this is just kind of an easy way to figure that out. And it's a double check too. I always like to have as many double checks as possible, especially on this piling. It's kind of one of the most important things on a bridge. And it just little video kind of shows it'll change here as it's detecting blows. You can change the microphone sensitivity on it because it will pick up traffic and wind some days. It's a little finicky, but when it's working, which is most of the time, it's pretty handy. And I think this video will work. Sound clean. Just video I took of the pile driving operation this summer. Just some things to remember. These things are right out of the spec book. Limit your deviation from vertical or your specified batter to less than 1/2 inch per foot of pile length, and keep the center of the pile at the cutoff within 3 inches of the specified location. If you get too far off, it can get into your rebar, and then they push your rebar, and that doesn't work because we need clearance on our rebar to the edge of the concrete. So those are things to watch, and it's amazing the things a pile will do as you're driving. They'll twist, they'll angle, they'll do all kinds of things. And then do not splice less than 10 foot of pile on when you're driving. At the end, if you get a 50-foot stick in and you need to add 2 feet to do your cutoff, that's fine. It's allowed, but you just don't want to be adding less than 10 feet in the spec book. And like I said earlier, and in my notes here, you'll get grease on everything. So just be aware of that. Them hammers are extremely dirty. So let's move on to a few other things here. I'm sure if you've looked at a set of bridge plans, you've seen the screed elevations. There's a lot of information you'll pull off of these too. There's screed elevation at every beam center line, and then it shows you the locations of those elevations. Your 10 equal spaces at this one is 126, so 12.6 feet. So you'll get your beams set, and you'll want to check your beams for camber when you're calculating your risers for your deck forms. So you'll shoot your beams. And that's this chart here. Just simple, I always use a level for doing this. Like I said, it's your most accurate way. And then here's your risers. And risers are, you calculate them taking your screed elevation, subtracting your beam elevation, and the thickness of your deck. Gives you your riser information. And typically your plans will give you a estimated riser height. Sometimes it's pretty close. Sometimes you have a bit of difference. I know last year we had one beam on our bridge that didn't quite get the camber they were expecting. So we had some risers that were a little taller than expected. That's an instance where you'd want to contact Bridge Division, the designer, and make sure they're okay with going a little taller. There's most things they want to know if it's not to plan. And you see I got them here in feet and inches, because as you probably know, Bridge likes to design things in inches, and contractors like to build it that way. So being, we typically use feet and tenths, but that'll make it easy for the contractor so they can continue their process. We'll look at reinforcing steel. So this is your common reinforcing steel plan sheet. You'll have a location here, like this is an abutment. You'll have the size of rebar based on 1/8 of an inch. So a number 5 bar would be 5/8 of an inch. You'll have the mark, which is an A100. So like your A would be a straight bar. if I had, like, I've got a C100 here, it's going to be a bar shaped like this. So that's kind of something you want to pay attention to, especially when you're checking your rebar. The number each set, so like this abutment should have 12 of the A100. And then the nominal length, that's your total length of your bar. That'll come into play when we calculate our weights to verify that everything is what it should be. Here's just an example of a wing on a bridge. You'll see like here you'll have 6 D100s. So it'll be 2 bars of the number 6 D100 bars right here along this bottom. And these can get a little difficult to read because you got a lot of black lines and no way to differentiate sometimes. So when you get a set of bridge plans, definitely study the rebar drawings because they're going to be something you're going to want to be familiar with. So this is another spreadsheet we've used. A lot of that same information, your size, your bar mark, your count, feet and inches. And then this table here comes out of the spec book. It's the weight per foot of the different size bars. Epoxy coated and non-epoxy coated steel have the same weights. There's no difference as far as our spec book is concerned. But rebar is paid by the pound. So you got your feet times your foot per pound, pounds per foot, your total weight. Great document to attach to your PQEs when you're paying for these things. Then there's no question on what's there. And we always put initial and a date of whoever did it and when they counted it so that we know, because sometimes we have multiple inspectors counting steel. So screed elevations. So here's that chart from before, just turned it sideways so you can see it. And there's the 10 equal spaces. So typically you'll mark the beam at those spacings, or your screed pipe that your paver will ride on. And then usually when we set the screed pipe elevations, we'll start at one end and we'll just move across the bridge. The contractor will move the paver along as we go, so that we have accurate numbers. And hopefully you can get it all in one run and they didn't start the first one too low and you have one where they can't adjust it down or up far enough. And then once that's done, you want to make sure you do the dry run with the paver to ensure you have proper deck thickness, slope, and clearance to the reinforcement. Those are big things because rebar too close to the surface always seems to be a problem, and there's a lot of older bridges out there that is a problem. So just make sure you're checking those things. Just an example of a paver. You see the screed here that will move back and forth on this bridge, and it'll screed off. It'll auger excess mud out the front. It's got some rollers to do some of the vibrating, getting a nice surface, and then there's some pans on the rear side that'll do the finishing. A few things to note. Spec book says maintain 25 cubic yards per hour. You just want to make sure you're staying ahead so you don't end up with your concrete starting to dry out If there's cold weather expected, we live in North Dakota and seems like our construction seasons get shorter and shorter every year. So just make sure they have a plan for cold weather, especially for the deck pour. You don't want to run into an instance where your deck freezes. Pay attention to how the paver's finishing the concrete. I'll show you a slide here in a minute that has some things that I noticed last year. Make sure your contractor's placing their burlap on that deck surface as soon as possible. Spec book says 15 minutes after the final finishing operation to avoid that top of the concrete drying out and cracking. Make sure you pre-wet your burlap. They can use a light fog spray to allow finishing before the burlap is placed. But as with all concrete and all contractors, they like to try to bless it with a brush. And we don't want that. Then you end up with some issues. So just only allow a mist. Most contractors, I think, use a pressure washer to give a mist over it. And then don't cover the burlap with waterproof material. That's right in the spec book. So just don't allow it. We've had contractors try it. So here's a couple pictures of paving a deck. And you'll notice that these lines in the concrete have shown up. Well, they showed up right away. And what we found out was that this second pan on the paver here, for some reason, it was just not sitting level, and they adjusted it multiple times throughout the day, and we just couldn't get these lines to go away. And they showed up on the 10-foot straight edge after the deck was done, but they weren't enough to cause them to have to grind them out. So it's something to watch for. Anything, not just this, but you just want to be paying attention to how the finish is because it affects your ride. The spec book used to call for the use of a 10-foot scraping straight edge to achieve the final finish. And it hasn't been in there since the 2014 version of the spec book. And that would have taken care of these marks. So it kind of puts it on the contractor to make sure that their bridge meets the spec as far as the ride surface finish. And I guess, like I said earlier, anything that isn't within specifications needs to be brought to Bridge Division's attention. We had an issue last year where when we were setting beams, the load cell on the beam or the crane said that the beam weighed twice as much as it was supposed to. And that got contractor worried, us worried, Bridge Division worried, the beam manufacturer worried, and the trucking company, because they were not permitted to haul beams that heavy. Ended up being that they had a service truck come out, recalibrate their crane, and their crane was off. So luckily that was issues were avoided, but could have been a bad deal. So just make sure you let Bridge Division know those things so that they can run calculations, figure out whatever they need to figure out. I guess with that, that's all I have. Unless there's any questions or comments.
Not seeing any question or comments. Thanks, Corey and Tyler. Next, we have Devil's Lake. You're muted, Chris.
Got to turn that on. Good morning, everybody. I'm Chris Beggs from Devil's Lake District. I'm gonna introduce our speakers that we have today. Up first, we have box culvert inspection from Dennis Horn, Brian Swatsky, and Julie Olson. I'll turn it over to Dennis.
All right, well, today's presentation is going to be on the inspection of a quadruple 12 by 12 box culvert on Highway 30 in Wells County. A few key talking points in this presentation will be stream diversion, rock base for drainage, overall box culvert installation, and reading shop drawings. Here we have the contractor's original water diversion plan on the left. Was to just use a 48-inch pipe for the diversion, which we didn't think was going to be sufficient for the water flow in that area. So we had them submit a new diversion plan on the right that was approved with an arch pipe of 103 by 71 inch that could handle more flow. Diversion was installed on the north side of the bridge. Contractor dug out the channel and lined with R1 fabric, which they glued all the seams together. After installed, they placed rock on all the fabric seams for extra protection in the channel. Backfilled and installed sheet pile to hold material back, since they still needed to drive across to get to the project location from the north side, as you can see. After the diversion was completed, the contractor then worked on finishing the sheet pile around the site. Once sheet piling was done, they then set up a 6-inch pump and drained the area. When they drained the area, they ran a hose from the ditch up the ditch to pump to a filtration site that was made up of fabric, small rock, fiber rolls, before the water could then work its way back to the channel. Contractor then removed the old bridge and started cutting the site to grade. Both abutments were left in place to hold back the embankment so the crane could be close to the hole while setting the box sections. Once the area was cut to grade, they then placed GeoGrid to cover all the box area plus the aprons. I have them stay a foot back on the apron ends so that when they cut in the drop walls, the GeoGrid is not getting cut into. As you can see when installing box culverts, that there's always going to be groundwater to fight with. Contractor asked to use some small rock, 6 inches of the 12-inch base, instead of all class 5 material. We approved the change, and they did not have to fight a wet base. In my opinion, all bases should have some small rock for drainage to help with the process of keeping the work site dry to get the job done more efficient. The next step is to get the Class 5 placed and packed to grade to get ready to set the sections of the box. Each section is connected with mastic on the joints to seal the connections. Here is a short video of showing them using a dozer to help squeeze the sections together. Here's a short video of the process of standing up the sections. These sections had to be hauled in on their side because they were so large. The contractor would then lift the sections off the truck and set on the ground by the crane. Each section of the double 12x12 box was a total of 26 feet wide by 13.5 feet tall. The 5-foot wide sections were 51,375 pounds, and the 6-foot wide sections were 62,150 pounds. To stand the sections up, they set an old semi-tire on the ground to cushion the box when they pulled to stand up the section. The very first one they tried with 2 tires, and that left them leaning too much at rest. So they switched to 1 tire, and that was just right. Here's a short video of them setting the sections. They used a 100-ton crane that they had to move for each half of the run. Before they swung in the sections, they would place the mastic on the top and side flanges of the sections being set, and also on the bottom of the one that it was going to butt up against in the hole. As you have noticed, the contractor left the old bridge abutments in place so that way they could get as close to the hole as possible to set the sections. Here are some pictures of the site during the setting of the first run to the finishing of setting of all sections to complete the box culvert. The picture on the right shows them finishing the northeast wing. These are some pictures from another box that was installed in 2021. Here the contractor had to come in after the box is set to then cut in 3 foot below the base to install the drop wall for the approach slabs to rest. They were going to start hauling in excavator buckets one at a time to fill in on the inside of the trench by the box, which was going to be a long process. I suggested that they use the crane that was with the concrete bucket that they already had on site to place the foundation fill, more accurately with less waste. They looked at me like I was crazy, but decided to give it a shot. They were very thankful for the idea because then they were able to use the excavator right in the hole to place the material on the outside edge while they placed the fill on the inside using the concrete bucket. Using this method, they were able to get the area backfilled more efficiently and timely with less tracking of the excavator. Before the contractor could do the flowable fill between the box runs, they have to install the end caps. After the first run is set, they attached a 2x4 to the side of the box and drilled in all the rebar to plan at 1 foot spacing. Before the next run is set, they install a 2x4 on the side of the next end section so that's ready to go in place once in place. These guys use foam to seal the edge between the plywood and the box, as you can see on the left picture. They then went and attached plywood and braces across the opening on the outside every foot and drilled 4 concrete screws per brace and said they were ready to pour. I suggested putting more angle bracing into the approach slab slots to get better support with all the concrete that they said it would hold. I was right. After getting 3/4 of the way full, the forms started to blow out and they quickly started putting the angle forms to brace better. Here I'm going to go through some different parts of the shop drawings. These shop drawings say that to tack the one end of the tie bolts on the box. We talked with the designer and they told us it was not necessary as long as someone is able to hold the one end while the bolt is getting tightened from the other. So that is what the contractor did. To anchor the wing anchors to the apron slab or wing wall footing, the design calls for concrete to be placed in the gap. The contractor made sure the area was all ready for approximately 4 to 6 inches of Class AE3 concrete, which is called out in the plans. They ordered the AE3 concrete from a local supplier and poured around all 4 wing footings, anchors to lock into place. As you can see on the left is prepping behind the wing and anchors. The picture on the right shows the concrete placed to lock everything together. After the contractor set the wing footing in place and started to place the wings on top, we noticed that the welding plates between the two were not lining up to plan. While casting the wing footings, they set the first plate right at 30 1/4 inches, but then set the next one at 36 inches instead of the 3'6" design. The inspector then went and checked all the other plate locations to the shop drawings, and this was the only one that was wrong. We then had to call the designer who got a hold of the manufacturer and then had to come up with a plan of how to fix the situation. They came up with just running a longer 1/2 inch angle bar between each location to weld and secure in place. Here you can see the plates are not aligned to plan. The picture on the right is just a closer view of the area. All the brackets on the box need to be welded by a certified welder in galvanized field welds according to section 105.06D. Once the welding is complete and cooled, they then come around and cover all welded brackets with galvanized spray to seal everything from the elements according to section 854. The approach slabs all needed to be welded together, and they also to the box culvert itself. After welding, they would galvanize the welds. Then they went around to all the connection pockets and used spray foam to seal up around the joints to get ready for the next step of mixing up Masterflow 555 grout to then pour in all the connection pockets. So they would spray foam all these joints here, so that way the Masterflow wouldn't fall through everything and just hold in the pockets. As you can see in the photo, they plugged the handling holes with orange plastic plugs. The contractor took a strip of mastic, which isn't called for, and wrapped around the plastic plugs before installing in the lifting holes to seal tight in the holes so water could not get through. After the sections were set, they would place gator wrap according to plan along the sides and across the top to help seal the joint. So all the way up and around. Here we have the before and after of the project. On the left side of the pictures, you can notice the difference in the washout area on the left picture to what we did by adding additional riprap and two 30-inch approach pipes. And that's it.
All right, thanks a lot, Dennis. We'll probably hold questions to, if you have any, you can give Dennis a shout here later and we can keep rolling with time. Up next, we have Dustin Legacy and Cade Nuring talking about existing pipe inspections and pipe lining. Take it away, Dustin.
Good morning. I'm Dustin Legacy, and today I'm going to take you through the process of inspecting our existing pipe and then implementing ways of fixing those existing pipe that are in pretty tough shape. I had the help of Kay and Earleen with putting together some of this information, and also from John Stork out of the Materials and Research for some of the equipment they have as well. So the first thing is the inspection to implement these repairs. So we need our initial inspection, the uploading our preliminary survey data to our GIS map that is located on the DOT webpage or MyDOT. And then we'll bring those videos in and evaluate them all in the office, each individual pipe. And then there too, we will figure out what is the correct action plan for these pipe. So what kind of fix we're going to do to them. So with the initial inspections, we are looking at different factors that lead to the need of the inspection. The tools involved for the inspection that we use and the forms that need to be filled out with each pipe as we do the inspection. So right away we got maintenance involved. So every section team lead would let us know if there was any issues with different pipes. So they would let us know what highway and what RP they were at. So, and basically to get these, we were looking for the voids in the embankment, in the roadway, any defects in the asphalt over top. If the end sections were separated, sinking, or just full of material, and other sections of the pipe, if they were separated or visible, that you could just see passing by them. And once we get those RPs in the pipe, we would go out with our pipe crawler, a smartphone or tablet for the GoPro app and the ArcGIS app. So the GoPro app would be the live feed we were getting as we were going through the pipe, and then the ArcGIS app has the documents you need to fill out. And then also our computer to view the videos once we have ran them. So our Devil's Lake Hive, as they call our hydraulic inspection vehicular explorer, has a GoPro Hero 7 Black on it. It is controlled by a Futaba controller, and the car itself is a Traxxas e-Revo remote control car. And then the additional pipe crawler that the state owns is a Materials and Research. It is a P350 Flexitrax crawler system. So a little bit of specs on our own Hive vehicle. It is a Traxxas e-Revo 1/16 RC car. It has 4-wheel drive. They say it's waterproof electronics, but I would probably more call it water resistant. It is geared lower than stock. When Materials and Research bought all these, they went through and kind of re-geared them and to help get through the mud. And they also come with 2 different types of tires, a paddle tire, which is better for the mud, and then a street tire. So if you're going through all clean pipe, and those are probably a little smoother and easier. And then our GoPro Hero 7 camera, it's a 12 megapixel camera. It has a hyper smooth video stabilization. It is waterproof up to 33 feet, which don't necessarily mean a whole lot since our car, I would say, is not. It has removable batteries, so as long as you got a few batteries and a charger with you, you can basically film all day. And it is capable of 4K video. So I guess here's a picture of the setup we got from Materials and Research, which I believe every district has one essentially. It's our RC car, the GoPro mount on top of a servo so you can control a Milwaukee flash headlamp that we use for the light. There's our GoPro 7, our controller, and then our cable. I don't remember exactly how long, but we haven't found a pipe yet that's not long enough for. And then the Materials and Research P350 Flexitrack with it's a P356 crawler. It's got 820 feet of spool length. It is waterproof up to a 330-foot depth. The pipe size it's rated for inspecting is 4-inch to 36-inch, although I believe all they've ever used it for is 18-inch at the smallest and as large as need be. So the camera has, I guess, your generic camera option. It can pan, tilt, zoom, and it videos in 1080p. It has an inclinometer and distance counter on it, so you can tell what the slope of the pipe is and how long the pipe is. And it's also powered by a generator. So these are just some pictures I got from Materials and Research that John Stork of the unit itself. And he said all districts are available to use this. Just have to call or email him to set up a time where they would come out and assist with it. A little bit of pros and cons versus our Hive and the P350 FlexiTrack. The Hive is quick. Average runtime is typically less than 5 minutes per video. I guess every once in a while we had one that maybe bumped up to 10, just depending on conditions of pipe and what kind of sediment and mud is in them. They're easy to use. The GoPro has better video quality. They cost around $1,200 to put together, so fairly inexpensive. And then transferring the data from the GoPro to your tablet and then computer is much easier. I guess the biggest con of it is they're not all that waterproof. We haven't, I guess, experimented too hard with it. We've typically kept it under, it's about 4 inches before we get to the electric motor in the car, so we've kept it under a 4-inch depth. Couple of the P350 Pros, it is waterproof up to 330-foot depth. Granted, I don't think we would ever see that in North Dakota. And it is powered by a generator, so it can run all day instead of being powered by batteries. The cons of it, it is a very heavy unit. The control module and generator is approximately 200 pounds. And the crawler, if it is set up with its, I guess most with the dual tires, all that, the crawler can get up to 100 pounds. It is a steep learning curve on using it, which makes it a little, you got to be a little more careful because it's also very expensive. That unit is around $50,000 to $60,000. So they don't really want you tipping it over and doing all that. And it is a slower process. I was told it takes around 30 to 45 minutes per pipe to get the video through, since with the camera movements being so slow. So some of the forms that you need to document and then upload is using that ArcGIS 123 app that can be on your tablet or your phone. So this is probably best to start it in the field because there is a map on it that pings your GPS location. So you can automatically put it, it automatically brings in where you're at, so exactly where that pipe is. And then you can also start filling it out by, there's questions on your surroundings and what the embankment and all that look like, the road top. So it's good to fill that out at that time. And then after you filled out about all you can out in the field, you can save it in your drafts and then wait to finish filling it out till you can actually see the video footage better in the computer, where you can pause and zoom in and do that kind of stuff. And then once the form is finished and finalized, it will get uploaded to the GIS map on MyDOT for the pipes. There's a culvert inspection page map that will bring all of the pipe that have been inspected and the forms filled out properly. So this is just the form you got to fill out. It will ask all the information. It's pretty simple to use, straightforward. And then when they have the good and fair ratings, they specify, there's kind of a little note in the side that tells you, I guess, what they're expecting for each rating. So if you're having problems on deciding what is what, you can kind of read. You can click on these over here and read what they're expecting. So after you get all these videos done and the pipe you plan on inspecting, you can bring it in for an office evaluation. So you download the video files to your computer. And then as you're watching these, you're going to be watching for any shifting, cracking, separation at the joints, and what kind of material is infiltrating. And then after you, when you start getting into this and looking at this, this will be when you open up that GIS form as well to finish the completing the answers that is kind of difficult in the field at the time. And then once you go through each pipe, this will be when you determine what kind of corrective action should be done. So the pipe might be in good shape, don't really need to do anything, or it could be just filled with sediment, so we're just going to clean it out. The pipe is cracking fairly severely and the joints are starting to separate, so then we'd probably clean out and do the lining. And I guess if they're severe enough, it'd be full replacement, but I don't believe we have found any pipe yet that have been that bad. Here's just some pictures of kind of our worst case pipes we found so far. We have some that are fairly severe joint separation. You see a little daylight on the left, and then you got some creative fixes over the bigger gaps where it looks like maintenance has used some signs to cover the holes to stop the material from falling into the pipe. And then on the right, we have a picture of some fairly severe cracking in one of the sections. So when it comes time for implementing the corrective action, like I said, potentially not do anything. However, most of these pipe we inspected were due to the existing ground, either holes forming or asphalt having to be filled in. There's usually some sort of issue why we're going to inspect them to begin with. So there's a lot that need to be cleaned out, and then they'll clean out and grout if there's any holes or if we do have any voids in the around the pipe on the outside. And then also the cured in place pipe. So this is just your kind of generic vac truck that I'm sure most of you have seen, that uses water pressure to loosen up all the sediment and then the vacuum to suck out all the mud it creates to get the pipe clean. Here's just another picture and kind of that shows how the water jetting works out of those. And then here's a pipe that they've have filled with their foam to get all the holes in the embankment and soil filled up, plus in the pipe. The middle is a grout gel that we used on a previous project. And then the picture on the right was kind of when it was all said and done. They put tie bolts in all the sections, and then also kind of epoxied all the joints to further watertight it. So the process of implementing our cured in place pipe, they need to do all the submittals, and then the process itself, and then our final acceptance. So with the submittals, they'll submit work drawings, a work plan, which each step is outlined and detailed on how they're going to do it. It can be used easily by the inspector, whoever is out in the field watching them perform this. And then the special provisions may require manufacturer representatives be on site for project personnel training. And then installing the cured in place pipe. The specifications will be found in the special provisions of each project proposal. They'll be project specific, so they will have to go through and clean all the pipe, which uses that vac truck to wash it all out and to vacuum it all up to clean everything up. And then once it is washed and cleaned out, will put a crawler through it to make sure it is suitable for lining. And then after we determine it is suitable for lining, they'll put their fabric tube, which they need the proper size to make sure it fits the pipe. And then once they pull it through, they'll cut it to length or close to length. They'll final cut after it's in place. They'll pull it through a pipe. Then they put the pressure to it to inflate the liner to form it to the pipe. And then they run the UV light train, they call, to heat it up and cure it. So which is part of that work plan that will have the curing times, the temperatures, and what kind of pressure they're going to be putting in it. And once the liner is in place, they will go and fill whatever kind of voids that we figure is around the pipe in the soils, which the SP will state what type of grout, how to locate the probable location of the voids, and what the method of grouting will be. Measurement for the grout will be derived from the contractor's metering device, which the gel grout can expand up to 16 times its initial volume. As you can see in the picture, we had one where the asphalt actually lifted at the crack that was over the pipe. So we had a bump there all summer long until we actually got to the road top and finishing. So here's just a picture of the lining itself on the left. And then on the right, this was a box that they used to hook the cable to and winch the lining through the pipe. And here's a picture of them putting together that light train I talked about, the UV light that cures the liner in place. And then here we have them putting the end caps on the liner that seals them and then allows them to put air through to blow up to the pipe. And then the top right is the picture of the light train in action as it's starting to run through it. And here is the kind of the finished product, I guess. The first two pictures is prior to them cutting. As you can see, the third picture in, they do cut it to as close as they can to the top of the end section there. So there really isn't any sticking out. And then picture of the inside, I guess what it looks like after it's done. And once they get done, they'll send the pipe crawler back through and get a video of it. And they will submit all these to the engineer, in which at that point the engineer will, I guess, say yay or nay, will accept it if everything looks good. And that is all I got, I guess. My information is on the page.
All right, thanks a lot, Dustin. Still kind of running right on time, so we'll hold any questions we have till the end. Up next, we have Ethan Kitch, James Wren, and Jason Hunter put together a presentation on how we're utilizing shared Microsoft Office documents. Take it away, Ethan.
All right. Well, thanks, Chris. Like I said, my name's Ethan, and behind the curtain today we have Jason Hunter. That'll be doing some magic behind the scenes. So today I'll be highlighting a few applications that the Devils Lake District uses to kind of streamline collaborating on projects throughout the course of the year. It seems over the past few years we've been experimenting with what documents and such as different SFN forms and other applications that are most beneficial to have multiple users within a document. And we found that most of the utilized ways of using shared documents are for collaborating on the four that I'll kind of be discussing today here, which is like writing letters, sharing punch lists, entering core data, and by and large is our ticket spreadsheet that we use. So today I'll be showing you all just an overview of our products, you could say, that we use, and if all goes well, we'll kind of give you a little live demonstration of the tickets. So kick it off here. So our first example here is writing official letters. It seems seems in engineering you kind of do a lot more letter writing than calculus and dynamics. So this application has been quite handy for collaborating throughout our office, and even if we have to work with anyone within the department down in Bismarck or different districts. So here's kind of a template. This is just the basic DOT's letter writing template. So initially, when I'm drafting letters, I just keep these on just our local drives, your F drive, in the districts. And then once I have my letter drafted to a place where I'm looking for input and discussion about how we should better my letter, I will then send it out for a shared review. And one thing to note is when you do send these out, they go on the Microsoft OneDrive, which is where you'll be working from there on out. So I'll kind of show you how that works here with a little example. And like I say, I got Hunter in the background here. So if y'all can see my screen here, here's a letter you'll be writing. So as you can see, I've already shared this with Hunter, but we'll walk you through the steps on how it works. The first thing you'll do once you got it where you want it to be, you come up to the right-hand side here and you'll click the share button. And that'll come up, and so a couple options. First thing is up here. Generally, you shouldn't have to change this, but if you do click it on here, it gives you some options of how you'd like to share the link within your organization. But it's defaults to set to the people you choose, which gives you the option of with internal DOT and external. So you keep that on. And then kind of the most important is you click down on the right side here and it'll give you some options. So if I want to share this with someone, for example, Jason today, I want to click it as a can edit. So that gives him the option to come in and edit the document as it's his own. You can also give the option of reviewing, where you can only give comments, like you'll see on my right side here. And then there's also the can view but make no comments. So that would be for a use of, say you want to share something with a contractor. So I would click on can edit, and then you type in who you want it to go to here today. It'll pop up with all the interdepartment people. So like Jason Hunter, and then you can just keep going. If I want to send it to other people, you can click their names as such. Then if you want to send a message of what you're sending with, like trial run, you just send it in with your message right here and click send. So on the receiving end, like Jason will receive an email and he will click it and he will open in, which will be looking like we got here today. When someone is within a document, their face will show up here. When they start typing, you'll get a little notification down here. As you can see, Hunter is typing away, and it's all in real time here. So works out pretty good for recommendations. Like I said, here's an example. If someone wants to leave a comment and not change anything, they can do that here. You can have a discussion on the side. You can resolve it. You can come in and delete the comment if you feel it's not necessary anymore. So like I say, we've used this for many different ways throughout our office so far, letter writing within the district, and have been very beneficial. I've been happy with the benefits of utilizing it this way. So our second item that we find is punch lists. So we're currently still designing and developing a punch list that is kind of adapted throughout our office. So I'm kind of going to show you a couple examples here. The one on the left was one of the first versions where we utilized Word. With this version, it was utilized internally just to kind of check off and keep track of the status of the item. And this worked okay internally. Like you can see here, we can add comments. You can just highlight or underline whatever your process may have been for when an item was complete. However, it didn't seem to meet all our needs. So therefore, this on the right here, we're planning to use this punch list this summer and see if it works pretty good for us. So this option here, you can have your spec, your code for the item, your description, your date of notification of when you told the contractor about the punch list item, and then you have a date completed that you can type in for when it was completed, and then initial depending upon who accepted the punch list, right? So we could share this between all project staff, and then we're also thinking of you can send it to a contractor on a read-only basis, so that way they can have the most recent copy of the punch list. It seems like you're always updating punch lists and you're resending via email, which can kind of get lost in the weeds, or just over the phone. So I think this would be a good way to collaborate and have the most recent version. With that, you know, you can also, there's the drop down menus here where you can organize. So if you have a list like on the left here, you can just have the most recent items at the top, or the items that have not been completed yet at the top if you would like. So I thinking this will work pretty good. We sized it so it'll fit on the iPad, since we all use iPads in the field. So we want to have it user friendly for the iPad version. So I think that'll work pretty slick. So our third application is the core data sheets. So generally as shown, everybody knows this is our core data sheet. What normally happens is you have this paper copy out in the field, you write your sample numbers down, you figure out your random numbers, your locations, and then you go out, you mark them, and then you send a picture or whatever your method is to send it to the lab, or you deliver with a piece of paper. So we figured, well, with the sharing Excel sheets, we could streamline this as well to make it a more organized and efficient process. So we came up and we just made an Excel sheet of the core data. This gave us options of, like you see in the bottom, we got day 1, day 2, you can have all your days. So that way you keep your core data organized, you know, you don't have sheets throughout your vehicle and binded or whatnot and losing. This also keeps it organized. You know, we can share this with everyone on the project. Most importantly, the individual in the lab will have this ready at hand. The big benefit to that is when you have this in the lab, you can just pull your sample, your station, your random numbers. You can just Control-C, copy that, and then bring it into your materials workbook. So that is, you know, very, very quick. You know, the process of sending via picture, and a lot of times what we've seen is that gets printed off in the lab. You have a paper copy, and then you're looking down, you're hand typing everything in. So that's adds to the probability of error. It adds a lot of time, and then of course you're just wasting another sheet of paper. So this is a lot more organized. It's a lot faster, and seems like everyone's been very happy with it. As well as, you know, like I say, it just keeps you organized. You can just add as many days. We have like the project numbers and all the pertinent information up here. We have the equation, so you just have to type it in once, and that just strolls through day to day. So. And with that, we have our fourth application. And this is by and large our most useful shared document. Kind of a few years ago, we started developing a way to get rid of the writing down on paper for ticket takers and having them utilize their iPads for data input since we have them. And that has kind of snowballed into our ticket spreadsheet that we have shown here. So this ticket spreadsheet allows ticket data to be input for all ticket takers simultaneously on their iPads, while being able to be viewed by all those that have access. You know, this has proven useful for multiple reasons. You know, examples being the lead inspector no longer has to contact the ticket taker for tonnage when calculating yields. You know, they can see what the main line is, what the approach tonnage, what the waste is, and they have it right there in the palm of their hand. You know, you can have it on your cell phone or your iPad too, which is the most place we use it. Other reasons are, you know, the lab personnel, they have this, so they can track when they need to go out to the road and take samples. They have right away at the end of the day for their cutoff reports, they got the tonnage for the day that's been put out on the road. And then other than that, we also, you know, this is spread with everyone within the district. So if you're in the office, you can watch in real time, watch the tickets come in. You know, if you see an hour gap or something suspicious, you can call out and see if see if there's a breakdown in the field or whatnot. I know we share it with our materials coordinator, so they know when they need to go take IA tests. So it leaves kind of a lot of options for everyone to see what's going on out in the field. So kind of looking at the layout of the sheet here, the top right, the way we designed it here is we have a pie chart here, which shows the total job progress. So and this example here, this was on our 281 project this summer. We just picked like day 10 down here. And at this point, we had this was a 72,000 ton job, and there's 23,000 tons remaining. So which is kind of shown in the red there. Also with that, we have everything broke down into columns. So you got your main line, you got your approaches, and then the third column right now is utilized as a waste column. Since generally we have a ticket taker on main line, they're filling this out, as well as someone on approaches taking tickets, and they're filling this out all at the same time. You're all in the same sheets, and you can see, you can watch as people are in here as they're both inputting data at the same time, which works very slick. So to kind of give you a demonstration of that, like I said, I got Hunter in the background showing how we do that. So I kind of pull in an example of our Excel sheet here. So as you can see, you know, I shared it like everything else. I can see that Hunter is in here, and you can see his typing here. So if Hunter's the ticket taker out in the field here, he's going through entering ticket data. So 1:30, he had ticket 1, 2, 3, 4 coming in. It was truck number 5, and it was a very large load. Probably should call HP on this one, but it's 3,000 tons. So for demonstration purposes, you can see how the fuel gauge went down. He's got 2,000 tons remaining on mainline, and for the total project of a 6,000 ton job, we're halfway done. With that, it's kind of like initially in the tickets by hand. We also have an initial column, so who's accepting the tickets. And then as you can see, pretend Jason jumped over and is taking approaches. He had a 250 ton load here, and now his fuel gauge is filling up. He had, looks like if there's happen to be a little bit of waste in that, there was 50 tons right there, which shows up as a minus quantity. So that'll pull back your total tons to be paid for. So on the right side here, we have daily tons produced. Now, we always seem to have, you know, the contractors, their daily tonnage report sometimes includes loads that went to separate projects, whether it be county, city, whatnot, and it doesn't include waste, right? So this daily tons produced on the right side here, that should match the contractor's haul sheet at the end of the day. And then we have daily tonnage here that shows what we will be paid off. So you will be paying off the daily total per day on here, as well as we have a job total, which compounds each day. Like here we're on day 1, but you could essentially have an infinite number of days here, and they compound each other. So with that, you know, we also have a notes section here where you can add a few notes in throughout the day. When, you know, miscellaneous things happen, a bump in the road, 50 tons of waste, as Hunter has here. So this, like I say, we have been kind of compounding on this. It started just as a little idea, and then of how to use a shared spreadsheet, and it's been developed into this, which we've been very pleased with. And like I say, everyone's been using it. We use maintenance staff a lot, so as well, we just give them an iPad, and same thing, they just hop right in, and it's pretty easy. And like I say, so I'll also give you another example here when it pops up. So this past summer, and this is the second example here, we had our passing lane project, which also had 2 separate projects combined with it. So there was, as you can see, a north-south project and an east-west project. And a lot of times there was paving going on, you know, all 3 projects at the same time. So there was 3, 4 inspectors out there taking tickets. So you know, here you can tell this was, I believe this went to day 42, but we got day 40 in the example here. And we got passing lane. We changed it up. So we have a passing lane column, a column for the north project, and a column for the east project that can all be entered in. And then we kind of adapted it so that way you can still maintain a waste column. This, as you can see here, so this is structured to fit your iPads. So, you know, you had your iPad screen to be right on the edge here. This top column from everything from like your header here is locked. So this just scrolls throughout the day. You know, on your iPad, you probably see down to like line 24. So this is the area where you enter your tickets and you can scroll and all your pertinent information remains on top here. So like I say, we've used this a lot. We're definitely very pleased. We'll see with e-tickets coming if it changes, but I know we did one project this summer that e-tickets, and we still, as an acceptance measure, we still put them in here. So looking forward, like I say, kind of envisioning making before day one, making a dashboard, so you can kind of look right on Frontier, and you're going to have charts and whatever pertinent information. Like I say, I haven't developed it yet, but that's the mindset, kind of an overall view of the whole project at first glance. It'll show you what days, paving, and tonnages. And we're also looking to kind of revamp. You know, it kind of seems to be a little redundancy here. So we're going to kind of revamp, kind of get the notes up top, so that way those are viewable at all points throughout the day, no matter where you're at on the paving, and kind of utilize some of this wasted space. So hoping to get that in this spring for this summer's project. So kind of in conclusion, we have found utilizing all these shared Microsoft products to be highly beneficial in, you know, saving time, keeping more organized documentation, and just in general collaborating as a team, so that way everyone kind of knows what's going on when we all have the same information in front of us. So you know, we are coming up with some other ideas. There's a lot of different ways you can come up with, you know, we're thinking of making, you know, an Excel spreadsheet with all the different bid items, you know, that you can kind of work on and collaborate with before putting it into cars. So you can see people's measurements and make sure it's correct and you all agree, and then it can be implemented into cars. So I guess if you have any ideas to expand upon these or different ways to utilize Microsoft products, feel free to let me know. Like I say, I'm always open to ideas, or if you'd like to learn more or have a copy of this, I can certainly send it to you. Like I say, so here's my email, or you can find me on Teams. So if you got any questions, feel free to let me know. And that'll be it for my presentation.
Thank you very much, Ethan. Very informative. That was kind of the big question I seen in chat was how can people get a copy of the templates that you've been working on. Also, if there's any other questions people have from our other presenters, looks like we're about out of time, but might have time for a quick one or two. Not hearing any. I'd like to thank all the presenters today. Turn it back over to Josh.
Thanks, Chris. Thanks, Ethan, Dennis, and Dustin for your presentation. It was good. So that'll wrap up our week 3. We got the final week next week, Thursday from 9 to 11. See you all then. Thank you.